I'm not sure why, but that's a little better. All right, so a logging company, if you haven't read this before, some of you might have started it, others of you not, but I'm just going to pretend we haven't done it yet at all. So 359, a logging company has a series of containment ponds along a river to transport the logs from areas in the forest. The logs are treated with this chemical, Haley 225, a made-up chemical, but it resists insect infection. So the EPA has established a maximum concentration of 80 parts per million in the holding pond. So you can't have more than 80 parts per million. They're going to test the water basically and, fail you if you exceed this limit. Each month, the logs from small holding ponds reach the main storage pond adjacent to the mill. Currently, 20 parts per million is added to the concentration of that chemical, Haley 225. However, 20% of the Haley 225 dissipates each month, so it evaporates or, it's gone. The table below shows the amount of chemical in the main storage pond for the first 3 months. So let's take a look together at what's happening. So far, there's zero of the chemical, so none of it is dissipated. This is the first month. We pour 20 into the pond. So the ending concentration is we've got 20 in the pond. Now it's the beginning of the next month. So it starts with 20. So how much dissipates during the month? It says 20%, right? So this is 20% of your starting value. So if I do 20 times 0.2, see how I get 4? All right, so this is going to be subtracted off. I lost those 4, and I added back 20 new parts per million. So 20 minus 4 would be 16, plus 20 is 36. 36 gets carried to the next beginning of the month. Then this number gets multiplied by 20% again. So 36 times 0.2 is that 7.2 number. So I'm going to take my starting value of 36, subtract the 7.2, add 20, and now I'm at 48.8. So I'm copying the 48.8 down here. So let's do row 4 together, and then I'm going to pause for a minute and have you do rows 5 and 6. So I'm going to take the 48.8 and multiply by 0.2 to get this number. So 48.8 times 0.2, try it on your own calculator, gives me 9.76. So I did 48.8 times 0.2. So I'm going to then subtract off 48.8 minus 9.76, and I'm going to add back in 20 because I'm dumping more chemical in the pond. So I'm going to take 48.8. I want to make this. There we go. 48.8. Oops. I'm subtracting 9.76, and I'm adding back in 20. So my end of the month would be 59.04 is what's left. And that 59.04 just gets carried down to row 5. So that's the start of the next month, 59.04. So I'm just going to pause for a minute. Can you try to generate these other 2 rows of numbers just so you understand what's happening to the chemicals each month? And I'm going to do it while. So here's what mine looked like. Did you get 73.78 as your last number, hopefully? If not, maybe check and see what number you did incorrectly, but you should see how much dissipates by multiplying by 0.2. So you subtract that number off and add 20 each month. So I just kind of copied from up above, but how much dissipates in month 4? That was the 9.76. What's the ending concentration at the end of month 4? That for me was 59.04. If you rounded slightly differently, no big deal. I mean, you're within a tenth probably of the right answer, so that's fine. I would count that correct. And then at the end of month 6, I'm at 73.78. What am I allowed to get up to? So remember they said 80 was the maximum. So question number 4 says, when, if ever, will the concentration exceed 80, right? The EPA standards. So I'd like you to take a minute and try to answer example 4. You can wait for number 5, because number 5 we're going to do together. It's an infinite sum problem. But I'd like you to try number 4. You might have to generate row 7, row 8, row 9. I'll talk about how to do this as a series at the end, but see if you can go through. Does it exceed 80? We're getting pretty close to 80 over here. So see if it's at the end of month 7 or at the end of month 8. So generate the next 2 rows. I'm going to pause it while I do it too. Does that make sense? Prefer that I wrote out row 7, it was 79.02. And then when I wrote out month 8, it went to 83.22. So basically the EPA would shut you down. So yeah, great, you had a business for 8 months, but now you're polluting the pond. So we need to rethink either how much of the chemical or how often. So it is a real life problem that there's chemicals that will keep accumulating because 100% of it doesn't evaporate. It keeps like increasing. Same thing when you're taking medication. If you start taking medication too frequently or too much of a dose, your body can't process it all. And it'll start to either poison your organs or be bad for you to be your body to keep that much of that medication in your bloodstream. So when you prescribe medication, it's for a certain dose for a certain amount of time. It'll continue to concentrate and it'll actually creep up. You'll actually have more than the dose in your bloodstream. So it's important to keep in mind how quickly things dissipate in our blood or in water, in the environment. All right, so what is the maximum concentration if I allow this process to go forever? If I was going to represent this as a series and I'm adding together things, I'm actually going to skip over to the summation on the back first, number 7, because I'm going to use number 7 to answer number 5. So write the amount of chemical after month N as a summation. So it's the sum from month 1, let's just say to infinity. I want my company to keep going every month. What's my starting value? I'm putting 20 every month into the pond. We've been using the number 0.2, and then we have to subtract it from the original amount. So really the ratio to get from month 1 to month 2 is the ratio of 80%, because that's how much keeps in the pond. So if you have a depreciation, you don't want to subtract off 20% every month. You want to multiply by 80% because that's what you keep. And then it would be to the n minus 1 power. This is a geometric series, so you would add month 1 plus month 2 plus month 3 forever. If they wanted you to evaluate an infinite sum, the formula is you take your first term and you divide by 1 minus the ratio. So that's exactly what we're going to do for question 5. We're going to take our starting value, which was 20, and divide by 1 minus our ratio, which is 0.8. And I don't know why this is now kind of a weird color, but like, why did my screen turn? Isn't this black and white now? Huh. I don't know what I did, but oh, it's just normal. Isn't that weird? I don't know. Okay, 20 over 0.2, because 1 minus 0.8 actually is 0.2. It goes to, isn't that 100? 20, it is. 20 divided by 0.2 is 100. So this process will eventually max out and plateau at 100. There'll be 100 parts per million consistently in the pond, which is over my 80. I want my company to stay in business. So if I'm the chemical engineer, I need to rethink how much chemical we're putting into the pond every month. I don't want to max out at 100. Question 6 says, suppose the logging company wants to adjust the amount of chemical reaching the main storage pond so that the concentration will basically stay at 80 and not go over it. What monthly chemical dosage will allow them to do this? We know that 20 is too much. So we could guess and check 10, 15, 19, or we could solve this problem. What amount divided by 1 minus our ratio will conclude at 80? And we know that 1 minus our ratio is 1 minus the 0.8, right? So we're really solving the question, x divided by 0.2 equals 80. So instead of guessing and checking, This is the infinite sum formula. What concentration divided by the ratio, or 1 minus the ratio, so 0.2 equals 80. How would I solve this equation? If I've got division and I want to get x by itself, what can I do to both sides of the equation algebraically? Yeah, just multiply both sides by 0.2. So I'm going to do 80 times 0.2 on my calculator, and that will tell me the monthly concentration that I can be allowed. So what do you get as your monthly concentration? 16 parts per million. So not too different than what I'm dumping in now, but if I can do 16 instead of 20, I'll keep my company in business, right? So they're not going to fail their EPA, whatever, test at the end of 8 months. Does that kind of make sense? It's a challenging problem. So that was